And we're now recording. Okay, so what I have in mind for today and tomorrow is that you have question and answer time at the end. Oops, let me turn this on. So first half, I'll do new stuff. And second half, I'm not sure. I might do some new stuff, but I was going to let you have a question and answer session if you have any. And if you don't have any, then you can just leave. Same thing for tomorrow. As I try to get this thing started for the shared screen. Yeah, here we go. All right, so again, time-wise, I think we're still good. So we're up to 11.6. So first half 11.6, second half maybe 11.6, but Q&A for the test. Same thing tomorrow, 11.7, Q&A for the test. And then Thursday, again, so for the tests on Thursday, I'll let you start with questions and answers. Then when that stops, we break and we take the test. So now today, 11.6, I'm changing the assignment even. Okay, it was originally 23 to 33, just make it 23 to 27 odd. So don't do what? Don't do 29, 31, or 33. That makes it a little bit shorter. Okay. Again, anything I'm doing in 11.6 will not be on this test. A reminder, this Thursday's test is just 9.1 to 10.2. This is what you have to turn in for homework. You must submit at least 70% of the homework. But again, that's really a joke because I end up doing a huge percentage of the problems anyway, so you don't have to do that much. Okay, so during the second hour, especially if you think of any questions you might have in preparation for the test, bring it up. And if not, I'll just let you go. And same thing for tomorrow. Okay, we don't have that much left of the course. Okay, so I haven't set the date for the last exam yet, but we do have plenty of time. And whenever I give the last exam, then after that, we'll just review for the final exam, which I have on my schedule here. So the schedule is all in flux, but we'll see how it goes. But for sure, exam is on Thursday. Okay, if you haven't put together your formula sheet, your cheat sheet yet, put it together so you can be ready for the test on Thursday. Okay, so again, Thursday you can ask questions, but if you want to start the test early, we can start the test early. Okay, so any questions about that? And let's see, Dimitri, I got you. Check anybody else in the chat. Okay, I think we're good. All right, so any questions about what's happening? Okay, so I'll do 11.6. Yesterday I did 11.1. They will not be on this test. This test is 9.1 to 10.2, which is still mostly trig. Okay, so we'll get started from 11.6. Here we go. We're still doing systems of equations, but they're nonlinear systems of equations. Okay, so if you look at the kinds of problems that we have, there's still two equations with two unknowns, but they're not necessarily straight lines. Okay? You might have other shapes. You might have circles and parabolas and all kinds of stuff like that. Okay, so 11.6. So let's see, today is Tuesday, the 27th. 11.6. Nonlinear systems of equations is what we're doing. So yesterday, we did systems of equations, but they were always linear. The graphs were straight lines. So let me show you back stuff we did. Like 11 to 17, those are all straight lines. 21 and on, they're straight lines. Okay. Today, however, they're not necessarily straight lines. So if you connect, let's say, a parabola and a straight line, they might touch at 2 points. Okay, or you could imagine if you have a circle and a parabola, they might touch at 4 points or something like that. Okay, so you're not necessarily going to have just one solution. You might have several solutions. All right. So let's just go right to it. We're going to be doing somewhat the same stuff, substitution and elimination for a lot of these. Okay, so we had to go up to 27. Let me show you those for those of you who don't have the book and aren't getting it. Page 827. We are. Some more. They obviously look a little bit harder after a while. 17. And then 23, 25, and 27. There's 23. 25 looks not so nice. There's 27. Okay. So I'll just do a bunch like I normally do. Okay, so problem number 1. Y equals 3x, y equals x squared. Find all solutions of the given systems. Okay, before I actually do it, a quick timeout. What do these look like? Right? This is a parabola which opens up. This is a straight line. So maybe something like this. So maybe they touch at 2 points. All right, so let's do substitution. Y is already solved in terms of x. So why don't I just put that right over there, right? 3x equals x squared. It's also the transitive property. 2 things are equal to a third. So they have to be equal to each other, right? X squared has to equal 3x because they're both equal to y. And I just solve this. Subtract 3x on both sides. 0 equals x squared minus 3x. Factor out an x. X times x minus 3. That doesn't look so bad. So what makes this 0? 0. What makes this 0? 3. So x equals 0 or x equals 3. And then y is 3 times x. So 3 times 0 is 0. 3 times 3 is 9. Right. So my solutions are the ordered pairs 0, 0, and 3, 9. So that's my solution set, right? 0, 0, and 3, 9. Not just a single point. And that does fit this picture. So they touch at the origin and some other point. That other point is 3, 9. Okay, that's all. That was fairly easy. The ones later on are not that easy, but this was fairly easy. Okay, quick double check of 0, 0, 0, 0, 0, 0. That works. 3, 9. 3 times 3 is 9. 3 squared is 9. Yep, they both work. Okay. So that was a fairly easy first example, I guess. Okay, then a little bit harder. 5. xy equals 1. Y equals negative x squared. All right, well, substitution. Do we already have one variable solve for the other? Yeah, right here. Y is negative x squared. So I just picked this up, throw it in there. X times y equals 1. But what is y? Negative x squared. That gives me negative x cubed equals 1. Multiply both sides by negative 1. X cubed equals negative 1. How do I get rid of the 3? Cube root. And the cube root of negative 1 is negative 1. Plug in -1. Let's see, -1 squared is 1, but the minus sign in front of everything makes it -1. So it looks like there's only one solution, -1, -1. Okay, double check, -1 times -1 is 1. Again, -1 squared is 1, and the minus in front of the whole thing makes it -1. So yeah, it works for both of them very clearly. Okay. Okay, next one I want to show you something like 7. Okay, see how for 7 you have x squared and y squared for both of them? I can work that out by elimination, just like the previous section where it was just x and y, right? Remember, if it said x, y equals a number, x, y equals a number, the only difference is x squared and y squared, but I can still do it by elimination. Okay. Two x squared plus y squared equals 17. X squared plus 2y squared equals 22. Okay, see, this is kind of the same as if it said 2x plus y equals 17, x plus 2y equals 22. The variables are x squared and y squared. Okay? But you can still treat them the same way. So that being the case, I can either equate the coefficients of x squared or y squared, except one's a positive and one's a negative. You can take your pick. Okay, so how about I multiply the second equation by -2. Right, what do I want to do that for? That's going to force this one to be a -2x squared. So when I add it to a positive 2x squared, they'll cancel out, right? So leave the top one alone. 2x squared plus y squared equals 17. And then the bottom one, right? -2x squared minus 4y squared equals -44. Add them up. X squared cancels out. Y squared minus 4y squared, so -3y squared. 17 minus 44 is a -27. Divide by -3. Y squared is 9. Do the square root property. Y is plus or minus 3. Okay, plug back into, let's say, the top one. Y squared is 9, right? So I'm going to change that to 9. You can tell it doesn't matter if I put +3 or -3. When you square it, you get 9, right? So I'm going to put the 9 there. 2x squared plus 9y squared, right? Y squared is 9 equals 17. Subtract 9. 2x squared equals 8. Divided by 2. X squared equals 4. Square root property. X is plus or minus 2. Okay, I'll let you write the answer the way that I'm going to write it. Plus or minus 2, plus or minus 3. Okay. However, keep in mind that represents 4 separate points. Okay, it's -2, -3, both negative. +2, +3, both positive. And then 2 possibilities where one's a positive and one's a negative, right? So it can be -2, +3, or +2, -3. So that's actually 4 points. Okay, that's a little bit more compact than writing them all down. Okay, we can double check it. See, if I square either plus or minus 2, that's 4. 2 times 4 is 8. Plus 3 squared is 9. 8 plus 9 is 17. That works. And then how about this one? X squared is 4. Y squared is 9. 9 times 2 is 18. 4 plus 18 is 22. Yes. So all 4 of these work. So I have 4 solutions this time. Okay. All right. Number 9. Y equals 1 minus x squared. Y equals x squared minus 1. Quick timeout. You should remember the graphs of these. In fact, they're opposites of each other. This is a parabola which opens up. This is a parabola which opens down. So maybe they touch at 2 points. Right? Where are those 2 points? I'm just guessing. I don't know. Maybe they don't touch at 2 points. All right, substitution is very good for this one, right? They're both equal to y. Since they're both equal to y, they have to be equal to each other. Right? 1 minus x squared equals x squared minus 1. Okay, get the x squareds together and the numbers together. So add 1 to both sides. Add x squared to both sides. Okay, so what, divide by 2? X squared equals 1. Square root property, plus or minus 1. Plug back in. If I plug in either a positive 1 or a negative 1, you'll get 1 minus 1, which is 0. Y equals 0. So I have 2 points, which you may write as plus or minus 1, comma, 0. So that means negative 1, comma, 0, or positive 1, comma, 0. So yes, indeed, they do touch at 2 points. Those 2 points happen to be plus or minus 1, 0. Quick double check. Plug in either a positive or negative 1. I get 1 minus 1, which is 0. And same thing over here. Yeah, it definitely works for both of them. Okay. All right. Okay, something which looks much worse. 13. 1 over x squared, 3 over y squared, 2 over x squared, 1 over y squared. Even though that looks weird, it's still kind of like number 7, where you have the same representation of the variable. 1 over x squared, 1 over y squared, 1 over x squared, 1 over y squared. Therefore, I should be able to do it by elimination. Okay. One over x squared minus 3 over y squared equals 14. Two over x squared plus 1 over y squared equals 35. Okay, so I claim this problem is kind of like this, only it's worse because of the fractions. All right. How about let me try to match up the x squared. So I want to force this to be a negative 2, right? So it's negative 2 over x squared added to the positive 2 over x squared to cancel out. So that being the case, let me multiply the top equation by negative 2. Like that. So negative 2 times 1 over x squared, negative 2 over x squared And then let's see, -2 times -3 is +6 over y squared equals 14 times a -2 is -28. Okay, so one more time, multiply this by -2, multiply this by -2, multiply this by -2. That way, when I add them up, these will drop out. Okay, so add them up, that's gone. 1 over y squared, 6 over y squared, 7 over y squared, right? 7 over y squared equals 7. Right? Multiply both sides by y squared. 7 equals 7y squared. Divide by 7. Y squared is 1. So by the square root property, y is plus or minus 1. Okay, plug back into first equation, looks easy enough. 1 over x squared minus 3 over y squared. It doesn't matter if y is either 1 or -1. When you square it, you get 1, right? So it's 3 divided by 1. It's 14. Well, 3 over 1 is 3. So let me just treat it 3. Add 3 to both sides. 1 over x squared equals 17, right? Okay, so if I plug in plus or minus 1, I get 3 over 1 is 3. It's 3, so if I add 3, 17. Okay, multiply both sides by x squared. 1 equals 17x squared. Divide both sides by 17. And do the square root property. So x is plus or minus radical 1 over 17. And I'm going to say you don't have to bother rationalizing the denominator. Just leave it like that. And y was plus or minus 1. So again, I have 4 solutions, plus or minus radical 1 over 17, plus or minus 1. Okay, that represents 4 solutions, negative, negative, positive, 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 negative, and negative, positive. Okay, so that's that one. Okay, then it gets a little bit harder. 15, y equals negative, blah, 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 and some other thing. Okay, so it's a little bit harder. Let's see how to make heads or tails out of that one. Y equals negative square root of x minus 1. X minus 3 squared plus y squared equals 4. It's starting to look harder, but I already have y isolated, right? This is isolated, so I just pick that up and toss it in there and see what happens, right? So x minus 3 squared plus negative radical x minus 1 quantity squared, which is actually not going to be that bad. Because, okay, what happens when you have a negative squared? Positive. What happens when you have a square root? Squared. You just take off the square root. So this is just going to be x minus 1. Agreed? Okay, so that's not too bad. X minus 3 squared plus x minus 1 equals 4. Okay, so one more time, I substitute negative, radical, whatever. I have to square it. Negative squared is positive. Square root squared, just take off the square root. Okay, so that's not too bad. There's no more fractions, no more square roots. I do need to multiply this out. X squared minus 6x plus 9 plus x minus 1 equals 4. Try to get a quadratic equation, so throw everything on one side, set it equal to 0. So x squared negative 6x plus 1x is a negative 5x. And let's see, 9 minus 1 is 8, subtract 4 is 4. Like that. So that's x minus 1, x minus 4, looks like. Okay, I'll continue up. Right, but that's x minus 1, x minus 4. Okay, so continue back up here. Okay, x minus 1, x minus 4 is that. Right, so what number makes this 0? 1. What number makes this 0? 4. Okay, now because I had a squaring operation here, I better, after plugging in, check my answer. Okay, so we're not totally sure that whatever I plug in is going to work. Let's plug in 1. 1 minus 1 is 0, square root of 0 is 0, negative 0 is 0, y equals 0. Plug in 4. Okay, that's not as nice, of course. 4 minus 1 is 3, so negative radical 3. So my potential solutions, which I better check, are 1, 0, and 4, negative radical 3. Not nice at all, but we better check it. Okay, 1 for x, 0 for y. Put a 1 here and a 0 here, that works. Put a 1 here and a 0 here, so forget that. 1 minus 3 is negative 2, negative 2 squared is 4. Okay, this one checks. How about 4 comma negative radical 3? Put a 4 here, I get negative radical 3, that's right. Put a 4 here, 4 minus 3 is 1, 1 squared is 1. Negative radical 3 squared is 3, 1 plus 3 is 4. Yes, they both check. Okay, so I have this real weird looking solution set. 1 comma 0 and 4 comma negative radical 3. Okay. Okay, next one is going to show you a 17. A little bit unusual. Y equals 2 to the x. Y equals 2 to the 2x minus 12. Okay, the way you want to think about this one is I can rewrite this like so. 2 to the 2x is the same thing as 2 to the x squared. Okay, to convince yourself of that, multiply this back out, right? If you have a power and then another power, you can multiply these powers. X times 2 is 2x, so 2 to 2x, so it is the same thing. And the reason why I want to write it like this is because 2 to the x, I can now call this y, right? Y equals 2 to the x. So put that as y. So I now have y equals y squared minus 12. And that's a lot easier problem, right? Okay, so subtract y on both sides because I have a quadratic equation. That means there's a y squared. So y squared minus y minus 12 equals 0. Okay. Paper's curling on me. Let me try to uncurl it again. Y. So what two numbers have a product of 12 and a difference of 1? That'd be 4 and 3. And you want to end up with a negative. Therefore, negative should go with the bigger number. Like so. Check it with FOIL. First, y squared, outer 3y, inner negative 4y, 3y minus 4y is minus y, and minus 12. Okay. So by the zero factor property, either this is 0 or this is 0. So what number makes this 0? 4. What number makes this 0? Negative 3. Now I go back and find x. Y is equal to 2 to the x. So y equals 2 to the x. Put a 4 here and a negative 3 here. 4 equals 2 to the x. So what exponent do I need to have floating up here to make it 4? Well, 2. And let's see, y equals negative 3. What exponent do I have floating up here to make this true? It can't. You might recall exponential functions are always positive, right? 2 to the x looks something like that. It can never be a negative quantity. Okay, so that's out. This is not possible. So my only solution is 2, 4. So that's the only one that works. Okay. All right, I'm finished with this paper. So let me do my focus job. And I'm actually not that far from being done, folks. Again, I wanted to give you some time, second half, for questions and answers. So we'll see how that goes. But otherwise, I'm almost done with this section. So here's that second column. And third column. And the last column. Okay. Okay, so all we have left are 23, 25, and 27. I was going to do 25. It's a little bit harder than 23. And then 27. And that's pretty much it. So I could dedicate time for the test for anybody who's interested in that. So let's do 25. That looks a little bit weird. Okay, use an algebraic method of solution, run the answer to 3 decimal places and check the results. Okay, so we'll just solve it. We're not going to bother rounding off. 25. Y equals radical x plus 1 plus 1, 3x plus 4y equals 12. Okay, this looks like it won't be that fun. Okay, I picked this up, throw it in here, right? 3x plus 4y equals 12. But what's y? Y is all this mess. So now I have to try to solve that equation. Okay, let's distribute the 4. 3x plus 4 radical x plus 1 plus 4 times 1 is 4. All right, so here's an equation that has a square root of an x and also an x. Okay, the usual technique for something like this is isolate the square root, throw everything else on the other side. So throw over the 4, throw over the 3x. So 4 radical x plus 1 equals. Okay. If I subtract 4, 12 minus 4 is 8. And if I subtract the 3x, it'll be 8 minus 3x, like that. Here's now where you want to square both sides. Okay, this would be nice. This is, well, not that nice, but at least it's just a square of a binomial. So parentheses squared, parentheses squared. Okay. You might recall when I had something like this, radical equations, you have to check your answer. So once again, just like the previous problem, it might not work. So double check your answer to see if it works. Okay, so 4 squared is 16. Radical x plus 1 squared is x plus 1. And now this thing squared is 64 minus 2 times a times b. 2 times 8 is 16. 3 times 16 is 48. Plus b squared, negative 3x squared is 9x squared. Okay, so I'm going to give a quick timeout again. Reminder, a plus b squared is a squared plus 2ab plus b squared. And if I have a negative, this is a negative. So a little timeout. The square of a binomial, a plus b squared, a squared plus 2ab plus b squared, a minus b squared, a squared minus 2ab plus b squared. Okay, so I'm doing that here. Square this, 4 squared is 16. Square root squared is just x plus 1. And then here I'm using this formula. I square the 8, 64. I square the 3x, then x squared. Then minus 2ab, minus 2 times 8, which is 16, times the 3, 16 times 3, 3 times 16 is 48, and there's a negative sign. Okay. Distribute 16x plus 16 equals 64 minus 48x plus 9x squared. Toss this over so that way I get a 0. And yeah, let me write it in order. 9x squared first. And let's see, if I move this negative 16x minus 48x, that's minus 64x. And then 16, move over, subtract from 64, it's 48. Like that. That might be kind of difficult to factor. It might factor, it might not factor. Okay, we could try stuff, but I think instead, let's just use the quadratic formula. Quadratic formula always works. So when I just jump to the quadratic formula. I need my calculator. Numbers are big. Okay, negative b is positive 64, plus or minus the square root of b squared. So 64 squared, 4,096, minus 4 times a, which is 9, times c, which is 48, over 2 times a, 2 times 9. So 4096 minus 4 times 9 times 48. $23.68, not a very nice number at all. All over 18. Okay, so it's roughly 48.66. It's not very nice. So yeah, we have to do a decimal approximation after all. 64 plus or minus 48.66 divided by 18. Okay, so we just have to work them both out. 64 minus 48.66 divided by 18. 0.85. 64 plus 48.66 divided by 18. 6.26. And then I have to figure out y. Y is the square root of x plus 1 plus 1. So if I add 1, that's easy. If I add 1, that's 1.85. So I want square root 1.85, and then take that answer plus 1. 2.36. And then 6.26. Add 1 is 7.26. So square root of 7.26. And then add 1. 3.69. So that's the best we're going to do because the answers came out so bad. 0.85, 2.36, comma, 6.26, 3.69. Okay. So that's that. Okay, and finally 27. Y equals 4 to the 2x. Somewhat of a similar theme to what we had before. Y equals 4 to the x plus 3. Okay, so again, 4 to the 2x, I'm going to write it as 4 to the x squared. Okay, and here, subtract 3, y minus 3 equals 4 to the x. That way, I can now pick this up and put it here, right? Y minus 3 is 4 to the x. Here's 4 to the x. So y equals 4 to the x squared squared. Okay, so 4 to the x is y minus 3. So y, here's 4 to the x squared. Okay, so I have to solve that. Y equals y squared minus 6y plus 9. Subtract y. 0 equals y squared minus 7y plus 9. So it looks again like quadratic formula. Y equals negative b plus or minus the square root of b squared. 49 minus 4 times 1 times 9 all over 2 times 1. 49 minus 36 is 13. 7 plus or minus radical 13 all over 2. Okay, so we just have to work both of those out. So 7 plus radical 13 divided by 2, 5.3. 7 minus square root of 13 divided by 2, 1.70. Okay, to find a y, we actually have to do logs, unfortunately. So 5.30 equals 4 to the x plus 3. Subtract 3. 2.30 equals 4 to the x. You might recall to get that down, I'd take the natural log of both sides. So ln, that allows the x to come down in front. ln 2.30 equals x ln 4. Divide ln 4, divide ln 4. Okay, so ln 2.30, ln 2.3 divided by ln 4, almost exactly 0.6. Let's say 0.6. So 0.6 comma 5.30. And then I do the other one, 1.70, plug it in here. 1.70 equals 4 to the x plus 3, subtract 3, negative 1.3 equals 4 to the x, and that can't happen, right? Again, exponential functions can never come out to be negative. Okay, so my only solution is this. That is it. Okay, and speaking of that is it, I'm actually done with everything I was going to do in this section, folks. Okay, so that means we are going to quote unquote break. We'll take our usual break. I'll start again at 12:10, but I have no more lecture. Okay, so I'll stop. If you have no questions about the test or anything, you can just disappear and leave. And at 12:10, I'll start the second half as usual. But if you have any questions, then Star and I will handle that. And if not, then everybody's done. Okay, so we're done for the day. If you want to ask questions pertaining to the test, starting at 12:10, you can ask them then. But if you want to just disappear from here on out, you may do that. Okay, all right, so that's it otherwise, folks. So I'll stop as usual. You may disappear if you want. Okay, folks, it's 10 after. So this is time for the optional question and answer period. You can stay as short or as long as you want, or if I don't see any questions or I don't hear any questions, I would just end the session. Okay, so at this time, if you want to ask anything about the test, you may either unmute yourself or put it in the chat. So you can go ahead and begin. And if I don't hear or see anything, then we'll just close it up. Okay, so CISO, Justin, or Chris, do you have any questions? Okay, 9.4, number 17 and 47. Okay, make a note of that. Let's see. 9.4, 17, and 47. Okay, anybody else who's here, you can leave anytime you wish. And let me double check. 9.4, 17, and 47. Okay, let me try to share the screen again, CISO. Sorry, it's never a fast process. Okay, 9.417. Cosine squared t sine t minus sine t equals 0. Find all the solutions. Okay, so I'll factor out sine of t. Cosine squared t minus 1 equals 0. Okay, I recognize 1 minus cosine squared is sine squared. So if I take out a negative sine t, and turn this around, 1 minus cosine squared t equals 0, like that. Okay, the opposite of cosine squared t minus 1 is 1 minus cosine squared t, and that's equal to sine squared t. So I have negative sine t sine squared t equals 0. That's negative sine cubed. Like that. Well, that's true when sine of t is 0. Okay. So on my unit circle, sine is the y coordinate. Let's see, they give you, ask for all solutions. So that's just multiples of pi, so t is equal to k pi, where k is an integer. So that means 0, pi, 2 pi, 3 pi, negative 2 pi, and so on. Okay, and let me go back and focus that. Okay, and then 47. Sine of 3 theta equals negative radical 2 over 2. Theta is between 0 and 360. Okay. So let me change this to something else. Let alpha equals 3 theta. See, which means I'm solving sine of alpha equals negative radical 2 over 2. We're comfortable with that. and 0 less than equal to theta less than equal to 360. I'll multiply all sides by 3. So 3 times that, 3 times that, 3 times that. And the reason why I want to do that is I want to know what happens to alpha. Alpha is 3 theta. So I'll put alpha in the middle. This is 1080. 3 times 0 is 0. Well, I'm sorry, this shouldn't have the line underneath it. Yeah, it wasn't going to matter anyway, but just to be consistent. Okay, this is 3 revolutions. So I'm going around a circle 3 times. When does this happen? Okay. All right, sine is negative in quadrants 3 and 4. That's here and here. So what are these in degrees? Well, this is 225. This is 315. But I keep going around because I'm allowed to go 3 revolutions. So I add 360 to this. Right, so 360 plus that comes out to be 585. Then I add 360 to this, 675. That's 2 times around, and I go around 1 more time, 3 revolutions. So that means I add another 360 to this. So what's 360 plus that? 945. And I add 360 to this. So what is 360 plus that? 1035, I believe it is. Double check here, 360, that's right. 36, 3, yeah. Okay, so that's alpha. Now I got to switch it back to theta. $585, 675, 945, 1035. Okay. Alpha is 3 theta. So now I just divide all these by 3. Divide by 3, divide by 3, divide by 3. And it gives me what I want for theta. Okay, so punch it in the calculator. 75 degrees, 105 degrees, and 195, and 225, 315, and 345. Okay, so that's it for that one. And let me go back and do my focusing on 47 there. Okay, so I think I've caught up with that. Let me check the chat. Okay, so I'll stop the share. Okay, so anything else, CISO or Justin? Otherwise, we're done.
None, thank you.
Okay, thank you.
Bye.
Justin, do you have anything? Okay. See if Justin, do you have any questions? I said, all right, I'll assume not. So Star, I'll close the meeting. You may leave, and I'm just assuming Justin's not there. Okay, so have a good day, Star.
You too.
See you later. Bye.
Later.